Section meeting. Yeah, it's fabulous. This is great. Before I get on to discontinuous electrification, Gareth mentioned that rail EI doesn't trip off the tongue yet.
Yeah.
But do you have trouble with that?
Yeah.
Or Becky?
Exactly.
You don't. You'll get used to it. So, right. Okay. So, what I want to do is to take you on a bit of a journey through what it means, what discontinuous electrification means, because it gets bandied around as a kind of expression. And people talk about bimode and trimode trains, and as if they're some sort of magic awful dust that you sprinkle on the railway and it makes all the problems of traction go away. I want to get out of that and get you to understand that there are some good reasons for doing discontinuous electrification. Incidentally, there always have been. And I personally worked on the Romford-Upminster branch line, that hugely important high capacity branch line that runs between Romford and Upminster in 1977. In the middle of that line, there is what amounts to a neutral section under a bridge. The bridge didn't need to be demolished, and it became the section in point between GE and the Pitsea lines. Since 1977, that's been discontinuous electrification, and I bet most of you didn't even know it was there. Anyway, never mind, nothing new. So we're going to get into some stuff which explains what discontinuous electrification is and what some of the implications are. I have to say that is not AI, that is a real picture. That is a Transport for Wales train. The work that they've done in the Cardiff valleys to electrify those services is spectacular. The transformation of what was a rundown and rather ignored transport network is now very vibrant, is used very heavily, and is, I'm sure, going to make a huge difference when it goes off the rails onto the roads as trams. So, hold on, what do we need to do here?
Yeah.
Okay. So before I start into discontinuous electrification, let's talk about freight, because Gareth raised something really important here. There is a need to decarbonise the national economy, not the railway, the national economy. And the railway can do lots of things to help that, but the biggest thing it can do is to reverse the results of the beaching era. The beaching era addressed a problem. The railways were run down, knackered, and didn't have a really good business case for a lot of the business that it did. The common carrier goods was a albatross around its neck. It was going to drag it down. Beaching got into looking at that and taking a position on closing lines that were no longer viable. We all concentrate on the closing the lines. We don't concentrate on the ill effects that beaching era had on freight. Freight got mixed up in this common carrier goods issue. And even though British Rail invented freight liners, which are the seeds of what we need now, that never really took off as something the railway owned. And answer this for yourself. Faced with a passenger service on a railway line, or running 20 container trains a day to get stuff from the ports, which way do you think senior management in the railway for the past 60 years have turned? Oh, freight, dirty, horrible stuff. We want sexy passenger trains. That's got to stop. We need the modal shift. We need to get traffic from the ports to the distribution terminals in the middle of the country on trains now. And there are about 5 tunnels that need to be dealt with, and that can be done with diesel locomotives now. The sooner we do it, the better it is for the economy, The sooner we do it, the better case there is for electrifying it. So anyway, enough of that. Strategic electrification is necessary because the freight industry, quite rightly, has bought some new locomotives, Class 99s, tri-mode locomotives. Sounds very good, doesn't it? Tri-mode. It can run on pantograph, you can start the diesel engine, or it's got some batteries as well. Well, its performance when it's in those other two modes, the other two, by the way, a locomotive has a pantograph on it. That's a locomotive. The other two modes that it tows around with it, the diesel engine and the batteries, are next to useless for mainline work. The acceleration and holding speed of a Class 99 is not going to enable it to, for example, pull a train up something like Shap. It's not going to happen. It can only do that with its pan up. And the batteries are for shunting around in the yard. They're not for mainline use. So it's an electric freight locomotive that can be used in degraded form running diesel. So the case for electrification, Gareth has said all this. Electric trains, they're powered by a fixed continuous system, are faster. You'll never find a TGV with a diesel engine on it. They're faster. They're more powerful. You buy a 6,000 horsepower electric locomotive, for 2 hours it will run at 12,000 horsepower. Buy a 6,000 horsepower diesel and 3 days after you've bought it, it's down to about 4,500 horsepower because the engine performance drops off over time. They're lighter. They don't knock hell out of the track, or the bridges, or the structures, or all the stuff that supports them. They're more energy efficient. The conversion rates are tremendously high, about 4% energy losses. Diesel engine about 62% at best, once it's getting old. They're quieter. I don't know if you noticed that. You listen to, do you remember Transpennine bought those Stadler locomotives? Oh. They were lovely, weren't they? Providing you're deaf, they were fine. Emissions free. Trains don't have exhaust pipes if they're electric. They're emissions free. They're less complex. There's less to go wrong. They do thousands of miles more between services than their diesel equivalents. And they're more reliable. But there are people who make arguments about discontinuous contact systems. They're not actually talking about discontinuous electrification. I've had these conversations with people in the DFT. They're not really talking about discontinuous electrification. They want electric traction, but they don't want the contact system. They want electric traction because it's better, but they don't want to put the wires up to power it. And the arguments that are put forward is a long period of disruption due to access. Yeah, it does take time to build it. It's not easy to build. It's too expensive. Well, is it? You decide your own answer to that. And it has an extremely poor record. The industry that delivers it has an extremely poor record. And I have to concur with that. I actually say, whenever I'm asked about this, that CP5 was shameful for electrification. The delivery of the electrification schemes in CP5 was shameful. The people who did it should hang their heads in shame. Midland Main Line is stopped at Wigston. More of that anon. Why is it stopped at Wigston? It's not a place where you think about discharging thousands of people who wanted to get to Wigston, is it? Then comes the next argument. Modern traction alternatives avoid the contact system, so we don't need it. Bloody thing. Horrible. We don't need it. We can do it another way. And other things are more important than to electrify the railway. ETCS is more important. Capacity is more important. Tomorrow, we need something better. We can't wait 3 years, 5 years for the electrification. Something more demanding needs to be done quicker. And then you have to consider the UK economy. I'm not going to dwell on this too, but CP5 performance, particularly wet, was a disaster in the minds of the politicians. It was a disaster. Then we get into a period of UK economic problems. We had Brexit, whatever your view on that is. Mine is very clear. We shouldn't have done it. It was a bad idea and it's buggered the economy up. Then we had a series of fantastic governmental car crashes, which not only said we Brexited and so the economy's going down here, but now we're going to have another go because we don't think we've got it going down fast enough. And they get it going. That was I was going to say a shag up, but that's rude, isn't it? I mustn't say that. And then we've got the other background issue. HS2 needs to be built. I am not arguing against HS2. It needs to be built. More of it needs to be built, actually, but it needs to be finished. But it is going to take the lion's share of transport's budget for the next 10 years. There isn't a bottomless pit of money. So having committed to that, well, there's not money for other stuff. But here we go. The electrification history repeats itself, actually, over and over again. Every generation of electrification engineers has faced the problem that this generation's electrification engineers are facing. That problem being that the UK likes to do a boom and a bust, and then come back and have another boom and another bust, which means that you train a generation of people who can do it, and then you put them on the dole. And by the time you get round to needing the next generation to do it, they're too old, or they've gone off and they've got a job somewhere else. Those challenges are there, they've happened over and over again. So that caught in it, it can seem that it's unique to your time. This is not unique. This is a problem of our national psyche. We're in the slump now. And it brings about what it has always brought about, the rush to look for panaceas, for things to avoid what you know you need to do, but you don't really want to do it because it feels too hard. That's what it brings. But, you know, in our current position, the history is always worth thinking about. I like to think about this from the point of view of thinking about the 1950s. Modernisation plan in the 1950s was in fact an electrification programme. The then CM&E of the railway, whose name always slips my mind, I've written it down, Robert Riddles. Robert Riddles put into the modernisation plan an electrification plan, of which I have a copy actually, that ran up to 2004. By 2004, the network would have been electrified. The network would have been electrified. But of course, boom, bust, put an end to that. Robert Riddles always comes under some criticism saying that, oh, well, he was a steam engine man, wasn't he? He was a real enthusiast for steam. That's why he did all these, you know, classes of BR steam like him. He wasn't. He knew that he had to keep the railway going until the electrification could get done. And among the locomotives that he designed was the magnificent 9F. So that picture on the screen is gratuitous because I like the 9F locomotive. I think it's fantastic, but it's not really relevant to discontinuous electrification, is it? The modernisation plan actually did do some stuff. It really did. It finished something that had happened before the Second World War, which was the GE electrification out of Liverpool Street to Shenfield, Colchester, Chelmsford and Southend. That was 1500 volt DC. But it also electrified Manchester, Sheffield, Wath, which actually was the second main line electrified. Shildon Newport was the first, but this one was in BR, primary pathfinding electrification. Unfortunately, though, MSW went the way of the world. Coal, transport, coal, traffic dropped, it became uneconomic. In order to get other things started, BR had to give up on the MSW, sadly. But between times, the funding dwindled, electrification began to fall by the wayside, and dieselisation came forward as the panacea. There's that word again, panacea. There's something we don't want to do, and there's this thing that looks easier. This thing that looks easier, I'm going to do. This thing that's difficult, I really want to do it, but I can't. Here's the lesson from the past. The modernisation plan bought some corkers. The industry, the locomotive builders stepped up. Oh, you want a solution? Here's the Bayer Peacock Hymec, a hydraulic mechanical locomotive that leaks oil and doesn't pull very hard and doesn't last very long. They went scrap. The Western warships, hydraulic, diesel mechanical. The Western engineers were stuck on not having anything electric. They went for scrap as well. There was a turbine on Southern, and even the still quite familiar to people, Class 31, wasn't exactly a rounding success when they were introduced. They lasted about a year, and then they decided they weren't strong enough, so they'd uprate the engines. And they did. They put bigger injectors in. They made all sorts of changes to them. And the engines blew up. The Class 31 has been re-engined as a fleet. That's the only reason it survived. And even then, it was re-engined for a purpose less than it was originally bought to do. There's the lesson from history. The industry says we've got the answer. Here it is. Look, diesels. Buy some. We'll sell them to you. We won't. Yeah, we know they work. Now let's think about the here and now, shall we? We're in potentially a batteryisation phase here. Battery, Stansted, trial, Great Westerns, old London Underground story running with batteries, the TfL trams that have had real trouble working on signalled parts of the railway because they're trams who don't have signals. And they can't, or couldn't, they've sorted it after a lot of work, they couldn't make them work, first of all. And they've even gone to the extent of taking diesel bi-mode IEP and taking the diesel engines off one of the coaches and putting batteries on it. So it's now a tri-mode, except that it's a tri-mode that in diesel can't perform because it's got not enough diesel engines. And it's got a battery that won't really do very much for it at all. Is anyone following this? What do you think I think of multiplicity of bi-modes being purchased before they're trialled? As an engineer, right, okay, there are people in this room who, structural engineers, there are track engineers. Would you, if I turned up with a plastic bridge, would you say, oh, wacko, we'll have hundreds of these, we'll do hundreds of them. If I turned up with a rail section, which was made out of papier-mâché, would you go, oh, it's not that cheap? That's great, isn't it? That's really good. We don't have to go to British Steel anymore. We'll go to, yeah. That's what we're doing with battery trains. People are turning up and selling us battery trains, untrialled, untested. Yeah, right. So the funder's perspective then. Primarily, we did our own self-harm. The railway's in the doghouse. We are not trusted. Delivery failed in CP5 spectacularly. The Treasury is opposed to the cost of rail electrification, implacably opposed. And I've been in the Treasury several times talking to them, and they kind of bloody don't. They don't want to know. But Network Rail needs to do something here. Network Rail needs to grow up. It really, I would say that now. I'm retired. You can't sack me anymore. Network Rail is monumentally stuck in CP5 performance. Organisations for delivery have not changed. Surprise, surprise, organisations that do delivery cost what GWEP did for its organisation. And as the GWEP organisation was 72% of the total cost, that's pretty stupid. That is damn stupid. Also, the outturn costs from CP5 are what populate the business cases for electrification. Let me just say that again. Let me put that to you in very clear language. CP5 was a monumental balls up. Stuff cost too much, took too long, and it was really, really bad performance. But it had an outturn cost to it. So the business case for Wigston North on MML is based upon those costs. Because, goes the argument, well, the responsible thing to do is to recognise that it costs that much and not give a false picture in the business case. What would you do with the people who make that argument? Just close your eyes and think about what you would do. How many people would be in the firing squad? Oh, sorry, I don't want to prejudice your thinking. While we carry on doing that, full electrification is unaffordable and the Treasury are not going to back it. That has to change. I've said enough on that. So, other forms of traction get support. Remember that the oil industry is resurgent. Venezuelan oil needs to be used somewhere. Doesn't it? COP30 couldn't even bring itself to allow the words fossil fuel to be in any of its output. COP30 did not use the words fossil fuel in its report because they don't want to offend the oil industry. Then we come on to batteries, the other technology, the new technology, if you like, the new kid on the block. Batteries have been proven in cars, vans, buses, etc., etc., etc. But the operational life of batteries in trains is not yet certain. We're going to hammer them. Compared to a domestic car, we're going to hammer them. Even compared to the Amazon delivery vans, we're going to thrash the batteries to hell. How long will they last? Batteries also provide no solution to long-haul HGVs. It's impossible. There's no room for the batteries to make a battery HGV for the sort of traffic that comes out of the container ports to the inland distribution terminals. That long-haul stuff is in diesel lorries forever, unless we change. So they can't do that on an HGV. What chance have you got on a freight locomotive? Zero. Absolutely zero. It's not going to happen. So caught between moving to net zero and not having a deliverable continuous electrification plan, what do you expect people who are elected every 5 years to do? They snatch hold of the panacea, don't they? So there's the big picture. I won't read that. I won't go into that. Perceptions. Here's the perceptions that the industry position has come to. Battery bi-mode electric trains are off the shelf. Go and talk to Siemens, to Stadler, to any of the manufacturers. They're off the shelf. Yes, technology. Nothing difficult there. We just build you trains. BMUs are therefore snatched at as the solution. They're the solution to our problem. Because of the diesel thing, the resurrection of oil, diesel bi-modes stand in the background. Just hear this, Of the schemes that were going to be part and parcel of the strong decarbonisation, Great Western, the IEP fleet was originally broadly 55% electric only. 45% diesel electrics. It got tough in GWEP as time went through, and there was a stage when it seemed that the promises to run the new trains were going to go down the pan, and the genius in the Secretary of State position at the time was Chris Grayling. What did the railway offer Chris Grayling? Oh, well, Chris, we can put diesels on all those trains. We can put engines on them. We don't really need them to be electrified. We can wait for that. Don't even need it at all in lots of the route. So we ended up with all of the trains on GWEP, the IEPs, diesel, EMUs, DMUs. Transpennine bought IEPs, electrics, because Transpennine electrification, I put it in the bloody budget. I got it in. I got the DFT to approve the spend on it. Electrification was supposed to be the first bit of Transpennine. It's now the last bit. So every IEP on Transpennine is a diesel. Every passenger bloody train that they're going to buy in Northern needs some form of bi-mode operation. And I guarantee that the numbers of, quote, tri-modes that are purchased will go up. Tri-modes being diesel EMUs with a battery. So this allows discontinuous electrification because of the backstop to be seen as the affordable, low risk, even responsible option. So enough of that, let's talk about discontinuous electrification. I want to convince you that it is not as attractive from a cost point of view as you might think to be discontinuously electrified. What is discontinuous electrification, first of all? Let's understand what it means. It could be continuous electrification over part of a route with other parts beyond that are not electrified. That's Great Western. You can get to Cardiff, but you can't get to Swansea. You can get to Reading, but you can't get to Cornwall. The second type is short gaps to pass discrete features, such as a difficult tunnel, lots of bridges that you don't want to rebuild. You can get past them. New electrification with gaps with no wire for long distances. This is beginning to find its way into the lexicon of things that are being talked about. Long distances of discontinuity in an otherwise electrified line. And then there's static charging facilities to charge the train when it's at a stand and then it moves. Now, here's Dearman's hypothetical scheme that we're going to talk about. Within this bubble is the bit that we're going to do the job on. We started off thinking we were going to electrify it all. Okay, so look, it runs from A to B. It has a branch line that goes off here to D. It connects through a long unelectrified bit of route to another route adjacent to it, and it has this branch out at E. So services from A to B have to be diesel bi-mode because of that. Services A to C, diesel bi-mode, much the same reason, but bigger there. The services A to D, they're battery bi-modes, BMUs, to get through these discontinuities and run the last 20 miles. This unwired branch line has some form of battery charging at the end of it, so they're BEMUs as well. Okay, fine. So far, so good. This little postage stamp will appear in the corner of my slides whenever I'm talking about something to do with the scheme. So the trains that are needed for this job now are not off-the-shelf EMUs. They're special trains. They're diesel bi-modes, they're battery bi-modes, and they take some extra cost. They cost more to buy. And remember, the diesel engine operation, they'll never perform the same as they will in electric operation. They're slower to accelerate, might find it more difficult to maintain speed, all that stuff. Battery bimodes for service A to B. Battery duty passing clearances at bridges is very light. That's good. Battery duty for 20 miles return turnaround is more demanding because you can get to a point where you get to the end and you've not got enough charge to get back. Batteries should be able to charge from the OLE, no static charging required, but that has some consequences. We'll come to that. BMU services for F to E, battery duty comparable. There is, however, no usable route for battery trains to get between A and F. That's here. That's this big discontinuity in there. I'm saying that's about 40 miles. Battery train manufacturers will tell you that all our trains can do 50 miles across on their batteries, but that's brand new batteries on a warm day, fully charged. 5-year-old batteries in the temperatures we had last week, you're not going to get past. So the fleet out here that runs around here can't get back here if the depot's here for servicing them, and vice versa. So you probably need 2 battery depots. Yep. Okay. Benefits though, if you look at it from the we don't like continuous electrification head, we've done away with about 250 single track kilometres of wiring. So 250 single track kilometres of no wire going up. Brilliant. We've done away with the demolition of 5 bridges. Good. Extensive and complex civil engineering to gauge clear tunnels isn't necessary. Difficult, troublesome structures where we have got to put wires up on a listed structure, well, we've avoided them because they're in this area here. So that would deliver considerable cost savings and time savings, but nothing in life is free. The cost of the fleets goes up. Bimode trains are more complex. The maintenance regimes are more demanding. Diesel engines are a sod to look after, basically. They need a lot of attention. You can't avoid dealing with diesel engines. And in fact, if you go to an IEP depot, I've been to 3 IEP depots, and I've never been on the depot where they weren't changing a diesel engine on the train, taking the package out and putting a new one in. So OPEX goes up. Whole life cost of batteries must include the renewal of the batteries periodically. How long are they going to last? If you look in the car manufacturers' details, car manufacturers tend to make extraordinary claims that our batteries will last you 180,000 miles. But the guarantee is only for 90. Think about the implication of that. And think about the implication of that for trains that have a much harsher charge-discharge cycle. Are they going to last very long? Depots need to be more complicated for the diesels and the batteries. Expensive firewalls, you can't have batteries burning the depot down. Fleet's more expensive to buy, blah, 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 blah. It goes on. Cost on the infrastructure. You haven't just avoided costs on the infrastructure, you've built some in. You need fixed charging at E. You need automatic power changer at 14, I think, locations. You lose N-2. You don't understand what that means. Most of you will come to it. You must understand it. I hope so. Heavy battery charging loads to the trains between A and D will mean that you have to do something more with the traction power. You've got to buy a bigger plug socket to plug into the grid. You've got 25 kV cable installations at the bridges. I'll explain what that's about. Additional train maintenance and potentially power supply upgrades on the other route because the blasted trains need it. So let's think about going through a bridge or a tunnel with a tight clearance. Us weird electrification engineers worry about 2 aspects of clearance: mechanical and electrical. In this tunnel, or bridge, whatever this is, these two trains can go through with their pans up, brushing along the bottom of a wire. They just can't do it live. Because if that's live, it will flash over to the bridge, tunnel, whatever it is. But that's how you get through a tunnel with discontinuous electrification. That's what we did at Upminster. That's what they've done in Wales. This is good, incidentally. This I wholeheartedly approve of. And here's how it works. You bring the live wire up to a point where you put an inline insulator in. That's half of what is called a neutral section that appear on the lines all over the country. You put dead wire through the bridge, this is a bridge, and then you go live the other side. And to keep the continuity, you put that cable through. So both tracks would do that, and you're then back to being able to do that. Pan stays up, the train automatically shuts off, runs through the tunnel, automatically turns back on, and the driver doesn't need to intervene. This is a discontinuity at a tunnel. At a tunnel, you're much less likely to be able to run through on dead wire, and there wouldn't be any point anyway, because you wouldn't have the momentum to get through the tunnel. So the wire for this terminates, and automatic changeover puts the train onto some other traction form, battery or diesel, doesn't matter which, it'll go on to another traction form. And the cable runs through, and at the other end, it will come out and just reconnect. So you've got continuity electrically, but you have no electrical supply to the pantograph. So that avoids demolishing the tunnel if you've got trains that can do it. Now, I touched on N-2 feeding when I was talking to you, and this is where I'm afraid I'm going to get rather anal about my electrification background. Traction supplies are derived from the grid. Cut a long story short, all of the plant and equipment is tremendously reliable. Long periods of time will go between there being any interruption to the grid supplies, but nothing's perfect. You can lose the supply from the grid. During my career, I've known it happen at least 4 times. The most spectacular one was when Tottenham Grid went up in London in flames, and it took out, for us, Midland Main Line, ECML, GE. We're not too far out, only the first 2 feeder stations out on all those lines. I was the engineer for Eastern Region at the time. That was exciting. So here we go. How do we deal with that? We deal with that by engineering the system so that it is N-1 and N-2 able to operate. What? N-1, N-2. At a feeder station, an individual feeder station, there are 2 traction supplies, 2 transformers. Each of those transformers is able to do the whole duty of the feeder station. So you've got parallel redundancy. They don't operate in parallel, they operate independently. Then down the track you go, and you get to the next feeder station, which is the same. Now those 2 feeder stations are inextricably tied together from a reliability and resilience point of view. And here's why. N means normal feeding. N means normal feeding. So this diagram that I've got up here shows red circuit breakers closed, which means electricity is flowing through them. White ones are open, which means they're not connecting. So look, no connection there, no connection there, no connection there. This transformer is feeding these 4 track sections down to the neutral section here. This transformer's feeding that way, blah, blah, blah. Yep, follow that? So now we're going to go to N-1, normal takeaway 1. In my example, for some reason, we've lost this supply. Okay, feeder stations stand on their own 2 feet at that point, because in N-1, you close this, therefore this transformer is feeding in both directions. under that condition, nobody will notice. Give or take, give or take. It will be normal operation. But then it gets worse because you get Tottenham grid up in flames or some other such circumstance. And we've lost this whole feeder station. Nothing here can feed. So what do? We close that. So that transformer, F1 there, is now feeding all the way back down here to the terminal end. When Tottenham grid went up, I tried to run the trains into London Liverpool Street off Colchester feeder station, which for those of you who don't know is 55, 60 miles out of London. The voltage in the platform at Liverpool Street was so low that two of the trains still had what was the voltage selection gear from 625 operation still working on the trains, and they selected 625 and came out the platform. Anyway, that's an anecdote. So there we go, N-1, N-2. Now, do you remember, this is about the scheme. This scheme, I'm arguing, would have 3 feeder stations running out down the main route out this way. So whilst they're all 3 in, N-1, N-2 is going to work because they've got an adjacent feeder station to tap into. But our fancy, cheap, cost evasion, modern best practice scheme isn't going to wire this. So now this one, you might know that one's there, but it can't do anything with it. There's no electrical connection between the two. So if now I lose this, all of this end of the scheme is dead until the grid rebuilds or whatever it is that needs doing. So the resilience of this system is now harmed by N-1, N-2 because they're separated as well. The loading on the traction supplies is larger and is larger for the battery charging and all the other things that needs to be done to those trains that are operating in the system. So not only have we traded the resilience, but we bought ourselves the need to buy bigger transformers, bigger supplies, and probably connect to a higher level in the grid at twice the cost and all that stuff. So discontinuous electrification doesn't come for free. The traction system that you have to build is radically, I would argue, different to the one you would build for the AMU normal operation. Battery charging. So, okay, I've talked about all the overhead line consequences, but down here, I've said there's a fixed battery charging system. If you accept that the fixed battery charging system is part of your traction operation offer to the public, then surely, logically, the battery charger has to have the same reliability as the traction system. It has to be N-1, N-2 capable, and yet it's one fixed location. So the actual consequences of that is that the supply that you need to buy is probably duplicated off 2 different parts of the grid to that battery charger. Otherwise, you can't guarantee it will be there. And if it's not there, your train service doesn't work. So there's more cost there than immediately meets the eye. You don't go to Halfords and buy one of these battery chargers with crocodile clips. They're bloody great installations connected to the grid. Okay. Some other things happen. The overhead line might need to be reinforced to deal with the thermal effects and blah, 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 blah. Yeah, so it goes on. In summary, I'm getting near the end now. I can tell you're flagging. I can tell you're flagging. If you need to get up and jump around, please do. No takers. The application of some discontinuous electrification is eminently sensible, but we should never ignore freight in this piece. It might be sensible from a passenger point of view, but if it means we can't get the freight off the roads, it's not sensible, is it? Full stop. If you need to compromise the resilience to get some electric operation, if you genuinely must do that, do it with your eyes open. Don't go and make the promise to the public that this is a great, new, reliable service when you bloody well know it's not. Because that's disingenuous and not very helpful for our industry, I would say. And yet I see signs that we're doing that. Whatever form of traction is chosen, I'll make the point on there that it should deliver for society. We're not, I think Gareth made the point in a different way. We don't electrify the railway just for the railway's sake. We electrify it to improve the lives of people. Think about TransPennine if it was electric. How many millions of people are served by TransPennine routes across the north of England? And yet we're making them wait an interminable time. And we're not even sure they're going to close the gap at the western end yet. It needs to be sustainable. In other words, we can afford it. We don't know whether we can afford all the batteries that we're buying. I can tell you, because I was part of a team that put it together, that a report was published by the Royal Academy of Engineering during the early part of this year just gone, which highlighted, among other things, the demand for rare earth metals to make batteries. If you project the straight line of the UK's increase in use of lithium batteries, and you keep the line going, by 2036, we will be using 90% of the known global reserve of lithium. We, the UK.
But that was before Trump found some in Greenland.
Oh yeah, of course. Of course. So he's a fantastic geologist, isn't he? Right, okay. So it needs to be sustainable. So to go back to my question, the case for, the green are the case for, the reds are the case against. The most important thing that I emphasise here is that we must not walk into designing railway systems which normalise lack of resilience and poor reliability, just because we're on a sort of theological pursuit of a new way of doing things. We must preserve the railway's operation as reliable and resilient. So there is a case for some. There's not a case for the wild dreams that some have injected into it. And at that, because I can see that nothing much changes in the PWI's history, the normality is that a section meeting, you go to the pub at the end of the bloke talking. So what you want the bloke to do is not talk for too long. So is there anything you'd like me to cover in more detail? If you've been listening, thank you.
I mean, brilliant, and exactly what I was hoping, which is a very clear picture that we as an institution and our members and the wider railway, please give the IMechE this presentation as well, needs to understand and appreciate. And crucially, most importantly, questions. Anyone have any thoughts and queries? At the very back. Yes.
I really appreciate your opinion on this, Pete, because I've tried to find it, cannot find the answers to it. Modern passenger trains are very power hungry for auxiliaries, heating, aircon, lighting. Batteries surely cannot last long.
Correct.
Just for that alone.
Correct. If you
take a third of the power output.
Well, I'm not going to mention the people that Paul and I have been working with on this, but there is a piece of railway which is planned to have that, you know, my bloody great gap.
Yeah.
There is a piece of railway that's planned to do that with battery trains. One of the questions that I've asked of that proposal is, how does that work on a cold winter's day when the train's got halfway into the long section and it's held up because of a derailment in front of it or whatever? What do you do about keeping the passenger environment going as the batteries go off the cliff?
We're going to have an extremely complicated brand new interlocking system we're going to have to come up with basically to test as soon as before the train even sets off from the buffers, that tests that it can complete the whole route. Another whole system of thing that we can
It's a very
build
real
failure
problem.
into.
Well, no, but what, you know, back to the HIMAG. Remember that diesel locomotive? Do you think Bayer Peacock published much detail about the oil seats around the hydraulic motor?
And the gear problems,
No, no.
This is
So do you expect Siemens, Stadler, all of them, to publish
we
information?
expect the suppliers to, but there's typically no professionals.
That's a very good point.
Yeah.
Yeah, that's, I agree.
Like, especially your air compressors, you've got heavy duty equipment
Mm.
throughout them, it all takes power.
Yeah.
Yeah.
Ian.
Hello. I'm shocked to see that Great Western figures are still being used for the cost per single track kilometre. But
And horrified? Could you be
Yeah,
horrified?
to be honest. But to get to the point,
Could you be polemic?
I'm trying to get to the point. Assuming that you do work on a sensible cost per single track kilometre,
Mm.
from what you're saying, the cost per single track kilometre of what I always call disingenuous electrification
Mm.
is going to be higher than a standard run.
Mhm.
So that must mean that if you can work out that figure, there is a break point where the length of the gaps suddenly starts to balance with the rest of the system. And I bet you know what that number is.
I think I do, but yeah.
But-
But it's a I mean, you're right. There's a crossover point.
Yeah.
There is. Yes. We'll some other time. I'll fill you in on that because it's not a straightforward answer.
No, I didn't think it would be, but that surely is the way to try and kill this off. 'Cause I see this as selling our children down the river. This DE business.
Mm.
It's really just chucking away the benefits and saying next generation pick this up.
Yeah.
So I'm with you all the way.
Yeah.
Yeah. Thanks, Ian. Yes. But I will talk to you about that.
Ben, and then we'll come to Roger.
On that last point, to what degree could a joined up railway start to build more effective business cases for operation of rolling stock and infrastructure together? Is there a glimmer of hope there?
Yes, of course there is. The jury's out on whether your fundamental words, how would it joined up? You do that because it has to be, doesn't it, Ben? But I think if there was less of the segregation, less of the interfaces, less of the need for apparent need for whatever question is asked during a project phase, if there was less of a need to put an army of 12 people on writing the question, followed by 10 more to finesse it, followed by 100 more to write the answer, followed by somebody to try and distill out of that bloody lot what it actually meant. If we can get to that, yes, but I'm not actually sure GBR is going to address that. Organisationally, I don't see the structure. I see the structure dealing with the operating railway, no question. But I don't see capital delivery being part of it. And if you wanted to privatise capital delivery, that would be one thing that could happen. I'm not sure it'd be that good because I do think you need an educated client to buy the right thing. On web, we did not have an educated client.
Absolutely, all the evidence is you need a very well informed client or bad things will happen. There's no counter to that. It is always the case that you need an educated client.
Delivery.
Roger, and then there's a question online that we'll come to.
Going back to the beginning, the business of electrification, steam was out, we were going to electrify and then we didn't. But surely there was a hell of a lot of lobbying there. All the private builders had run out of work and were going into insolvency, and the government thought, we can keep all our friends in business. So I think that,
Do you want the cynical, real cynical comment from me in response to that?
yeah,
Why do you think the delivery vehicle for HS2 and TransPennine is largely constructed out of the construction companies who are profiting from its being?
yeah.
And why was the initial HS2 Limited formed from largely highways people? Because you'd seen the demise of Roads for Prosperity in the early 90s, mid 90s
Funny,
road
isn't it?
building. Yeah, fiefdom.
Ernest Marples, he of Marples Bridgeways, people who built the motorways, caused one of the downturns in electrification in the 1960s when he cancelled West Coast north of Stafford. Thankfully, that didn't last long, but is that, do you find that interesting?
I have a weekly podcast where I get angry about this stuff, but I could possibly,
With Great Western
Yes.
disaster, surely that would never have happened if there hadn't been privatisation. Because BR would have still had all the expertise and it would be a carry on of the East Coast.
Agreed.
Yeah.
If the implementation model had continued, Roger, what would not have happened? That's
Yeah.
right.
But isn't there the Treasury come into this?
They do.
Well, if we have bimodes, the rolling stock companies have to cough up a lot of money and we don't have to spend so much. So there's that distorting everything. We've had some great examples recently of bimode performance, like the settled car diversions have been fantastic. You know, most of the 10-car trains have ended up 5-car because they didn't like climbing hills. They do it once, but they didn't like climbing hills. That we've certainly
That's a teeny weeny disadvantage, isn't it?
I went out and they put the heating off to get up.
And everybody forgets the weight of these trains and damage to track and everything is a function of weight.
It's worth, if I may briefly, Roger, on that point, you were talking about the contract change from the percentage of basically making all of them bimode from electric fleet cost £1.3 billion on the rolling stock contract, which is easily enough to have just done the full electrification to Swansea and via Bath to Temple Meads and up to Oxford as well.
Exactly.
Interesting. Yeah. Just I always want to clarify that point. £1.3 billion extra on the IET contract for the GWR IETs.
Where did our chief executive of Network Rail come from at the time that decision was made? Can anyone remember where Mark Kahn came from?
It was his principal contract.
Shell Oil?
It's dangerous to have two cynics stood in front of the sorry.
Principal contractor from the US.
Yeah, Roger, sorry, quickly, because then we'll go to Richard online next. But I'm conscious I interrupted you there, Roger.
We finished.
I think Roger had done.
Well,
Quickly.
I say you on the southern region, there's these ideas that we can have bits of overhead electrification on the long gaps in third rail. Well, what is wrong in just filling these gaps with third rail?
Nothing, really.
I think
Anything,
that's the way it's going now.
Mr. Cheaper,
Yes.
That's the way it's going now.
nothing is wrong.
That's the way it's going now.
is it?
I think probably, yeah. I don't think there's not going to be long lengths of overhead line on the southern.
Common sense is coming in at last.
Typically.
Yeah.
We can go
Slowly.
calibrate.
But on the southwest main line, it's likely to be a discontinuous form of third rail.
Yeah. I'm going to jump to. Oh, go. Thanks, Rod. Yeah. Useful observations. Richard Nesbitt, you feel free to unmute yourself and shout your question. It should come in through the speakers. Yeah, we're getting there. There we are. No, nearly. If Richard, if you're having trouble with your mic, feel free to just type the question, then I can read it out. You've remuted yourself. Tell you what, Richard, you type out your question. I'll just quickly go to Chris Pollock here. Chris, go for it.
Peter, I'm very glad to see that you're not ignoring the front. I could just go off on a bit of a tangent. There was a scheme approved, I think, for a trial of electrified HGVs with overhead wires, I think on the M180.
Yeah.
And that's gone very quiet. I don't know, do you know anything about that?
Yeah, because it was a bad idea.
Well, I can see there were some challenges, yes.
I mean, the great fuss about that, if you like, that's the wrong word, but the great impetus for that came from experience in Sweden where they tried it and
I've been in one.
got somewhere with it.
It was one of the grailing ones, wasn't it?
It was Chris Gray. Yeah, he's a genius. They managed to have some success with it in Sweden, but even there they ended up, because there's no guidance system under the vehicles, they ended up having dewirements where the pan comes off the wire and stuff. But the bit of that object lesson for me is imagine how difficult it is to keep HGV drivers in the slow lane on the M62 today. I mean, you end up going, you're driving along and you slow down behind an immense queue of traffic. And eventually, when you get to the point that's causing the hold up, it's because some silly sod in an HGV's pulled out to overtake, and all he can manage is about 0.8 of a kilometre per day faster than the one he's overtaking. So everything backs up behind. Now, if that level of discipline were to manifest itself with wires above it, not only would you not be moving in the queue for a long time, but you wouldn't get past it at all because the wires would be wrapped around the vehicles. And I think it's a pretty daft idea. Do you know what the dafter one was? There was a dafter one.
Right.
You know, you can put your mobile phone on a pad.
Yes.
And it couples magnetically to charge. Some bright spark got into the Treasury DFT and convinced them that you could run coils all the way down the motorway. And therefore the lorries would be constantly coupled to the magnetic field below, taking power from...
And watch 1 in 30 people who have some sort of heart appliance keel over as soon as they enter that bit of road. Yeah. It's Stephen, yeah, go for it. Sorry.
Peter, to me, the elephant in the room is not electrification. It's actually the UK rail industries and Network Rail particularly ability to deliver large projects at a reasonable cost with a, speaking from my VR experience, what I would call a reasonable size of project overhead.
Yes.
And I mean, until we address that, surely, we can argue until, we can argue the toss with the Treasury until the cows come home, but unless we can actually get that project costing down, that project overhead down, and how, I'd be very interested in your thoughts and maybe others' thoughts in the room about how we actually do that, because until we do, the industry is in a real bind.
I'll give you 2 things, I think, because that's sometime over lunch tomorrow. So, there are 2 things. A book you should buy if you haven't got it. Bengt Flyberg's book, How Big Things Get Done. It is such a really impressive read about the syndrome, which is mega project syndrome.
It's the last good thing he wrote, incidentally, but it is very good.
It's brilliant.
Everything since then, but that is very good. He got obsessed
with
with
a magnum opus.
Yeah, exactly.
It's brilliant. You should get a copy and read it. So what that says is that the more we complicate the job that's to be done, the less likely we are ever to deliver it on time and to budget. And his great expression about mega projects, his strapline is over budget, over time, over and over again. And he's right, and he proves it with data as well. So that's one issue, that we overcomplicate things. My TransPennine electrification scheme that went into the 2009 electrification bucket was to electrify the railway, not rebuild it. The example that I'd like to quote is that if you want to change the door handle on a station somewhere on the ladies' toilets because the handle's broken. If you're not careful, the way our industry is today, that will fall into some evaluation process, which will decide that, well, the door should be done as well, really, because the door's probably a bit weak. Well, if you do the door, you've got to do the door jam. Oh, well, no. If you do the door jam, you've got to do the lintel, you've got to do the wall above it. And wait a minute, this station's always been in the wrong place. We should move it 3 miles down there. Oh, and if we do that, there's a line speed improvement, which will get us 12 seconds to get further on. But then we'll need the junctions remodels at the station at the other end, because they'll all be stacking up trying to get in. That is the problem. The electrification of Transpennine begat the monstrous job that's going on out there now. It's a good job for the north of England. It's got some scope in it I would never have seen in, but it's a good job. But the electrification got entangled in that scope. It's not creep at that point, it's scope acceleration. So I think that's important. And I just think that we make a song and a dance about things that don't need a song and a dance made about them. I used to get asked to do risk assessments of things on Great Western. And I would genuinely sit and frown at the people asking me, saying, well, what is it you want me to do to make this risk assessment? Well, you've got to do all this stuff. We've got this process and procedures to do it. And I would say, no, I'm not doing that. I'm not doing that. It's not dangerous. Okay. Skilled people doing it, it's all right. Oh no, you can't say that. You got to. So that would go off to the safety team, who would spend 3 months proving that the butterfly couldn't fly. There's culturally something we need to change in that respect. We've got to stop the thing that says we've got a level of safety now. How do we get better? Instead of asking, we've got a level of safety now, is that adequate? Yes, stop. There's no process that lets you stop. Every time you do it, it needs to get safer, apparently. Anyway.
I think to add my response to that is, for what it's worth, most of what we do on the railway should not be delivered as projects. Like, why are we doing these things as projects? They should not be projects. Right. Like signalling, track work, we have got more of a rolling programme. You know, we presided over a fairly substantial rolling programme until devolution kicked that in the backside. Pretty much everything, station mules, AFA, you name it, it should not be a project. It should be a dedicated team, national or regional, that is delivering this stuff and has been delivering for 15 years and will deliver it for another 15 years. And that would solve a lot of the problems. And the trouble is that requires treasury commitment.
And that was how East Coast Main Line was delivered 1 year early and under budget, because the build was simply modular. Every mile was the same until you found something that was in the way, and then you sorted that out and got it out of the way. But every mile was the same. Every substation was the same. They came on a low loader from the factory. Everything was modular, and it was just like a job. It wasn't a project as such. Yes, yeah, agreed.
Liam West is saying, given that GBRF has bet on the new Class 99s, what does this reflect in confidence in electrification for the wider supply chain? Noting the choice to choose diesel, largely diesel over battery. I mean, it is a tri-mode, the 99, and it's a more powerful than the 93, which is nominally the same thing. But I suppose it's a short answer to that, which is not a great amount of confidence. But...
Well, I mean, the Class 99 is a stepping stone to the ultimate railway that's finished properly. It will get you past the obsolescence and end of life of the Class 66, still with freight running, and it does that, maximising the use of electric traction where it can. Good. But my point about the future plan is that we should be shutting the gaps. So we've got all of the route electrified for the 99 to work as an electric loco. Then we can take the diesel engine off it and it'll be even better.
Yeah. Usefully, all that extra junk that's attached to a nominal electric locomotive is quite good for the electric locos are too light problem in a way. So you have added a bit of extra weight. So in a way, it solves one of the challenges of the electric loco for freight. Once it's just a bunch of redundant scrap that it's hauling around.
Have you ever been to Switzerland or Germany? There's these little cocoa locomotives that come creeping out, and the place I've seen them often is at Bern Station. They come creeping out across the station, and the front goes by with one of these little locomotives on the front, and then it just now, by my recollection, Switzerland isn't one of the lowland flat countries, and therefore, ergo, one would assume that the tractive effort that those things are able to put on the rails is enough to pull the train along. I don't think it's an issue. Really, I really don't.
It's funny how much, the freight operators seem to suggest it. Right, last question is going to be from Paul, I think. Unless there's anyone else with a query, right, Paul, and then we will say last couple of words.
Less a question, more just an observation. Something that one of the things that Peter maybe hasn't expressed is the reason against or for the alternative traction methods is that you don't need electrification. And that's just a total fallacy, that the move is towards battery electrics that all need some form of electrification. So if we're got to put in the electrification, we've got to have the interfaces into the supply chain. You need all that energy plus more, because of the charge discharge cycle isn't 100% efficient. When you get that energy, you've got to provide it at a faster rate because you're not distributing it throughout the route and the journey. So all of this means that it's just really reinforcing the point that Peter's made. But please, in any discussions you might have, emphasize the fact that if we're going for battery electrics, we still need electrification. Where's that going to come from? Where's the planning for that? How do we make sure that the infrastructure is set up to provide that facility? And leaving it to the train suppliers to say, oh, we'll just go and plug you in another socket at Timbuktu, or Buxton is renowned as a place that's supposed to be really difficult. Oh, we'll give you a supply at Buxton. All that goes with that, including one of the things that's come out of Northern, is they've looked at it and said, we'd like to put some charges in at Buxton. Oh, but it's got all this signalling that's not going to be compatible. And then it's Peter's toilet handle door issue. It just snowballs. So let's get into the idea that we've got to find, coming back to Stephen's point, an effective, cost-efficient way of doing electrification.
It's the delivery model,
and how we deliver it effectively. And then if there's an interim measure, or there are some cases where it's a dedicated railway, like in the Valley lines, it can be adopted as long-term discontinuous. But generally, the discontinuous ought to be an interim measure for to allow early adoption, but then for the longer term to fill those gaps.
Thank you, Paul. Yeah. Right. I'm going to round us off given time, but there is time for conversation afterwards while the chair dance happens. Peter, thank you so much. See you next month. Third Thursday month in here. Since and Sue will be presenting Getting Boots Off Ballast. Should be brilliant. Everyone here, don't be a stranger. See you next time. Thank you so much. Right, and pub, and also some room rearranging. But marvelous. Thanks, and thanks to everyone online. See you next time.